Yo, 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 Math by the Moon here with another video. Today we're going to piggyback on exponent rules. We're going to jump into the rational exponents, which is actually what this whole lesson is in this unit. It's about that, but it felt like we had to go backwards before we could go forward. So had to make sure you knew your exponent rules before we could start throwing fractions in there. So now exponent rules with fractions. Here we go. Let's get after it. All right, so I even changed this slightly, a 1 degree shift here. We got even roots of negatives always have I. Odd roots of negatives always need a negative answer. So let's go to the actual content. Don't forget I squared equals -1. All right, so to add or subtract fractions, because we're going to have to do that now. To add or subtract fractions, we definitely need a common. Come on. Oh, you want to do that, do you? Okay, you're cute. All right, we need a common denominator. And some of you are going to love the alpha y equals in the TI-84. You're going to love that in your calculator. Okay, to multiply fractions, you go straight across. Now that means the numerator times the numerator over top of the denominator times the denominator. Okay, I guess I could have probably fancied that up a little bit and just use some parentheses. Numerator times, how about we do that? Oh, that's going to look super cool. Oh, that's not cool. Numerator times numerator, denominator times denominator. That's how you multiply fractions, straight across. When we're doing the exponents, though, it gets a little funky because I usually use the exponents with the slash, so it's kind of slanted, but that's why I want to write it like this. Numerator times numerator, denominator times denominator. To divide fractions, is really the multiply by the reciprocal rule. And in this case, I think really what I want you to see is the different application. But we're gonna put this one in here anyway, because later on in Unit 3, we're gonna end up dividing fractions that are complex, and you're gonna need to hear this again. So let's just say dividing fractions is the same as multiplying by the reciprocal. Okay, just so you have it. Some kids have heard it called the numerator stays the same, the denominator, or the operation, the division changes to multiplication, and then you take the fraction and flip it. So you've heard same change flip maybe before for that. Okay, we're actually not going to use this right now. Okay, when we see a division problem, we're going to subtract the exponents. That's the like base rule for division. The quotient rule is subtract exponents. So you're actually not going to use this one yet, but I feel like we're talking fractions. We might as well get it all out there. All right. So here we got some examples, and I used all this first 3 questions there. 1, 2, 3, 4. Yeah, you see it. It's weird. 1, 2, 3 are numerical, right? So the base is going to stay numerical. The base is going to be the same. We just have to know what application of the exponent rule we're using. So this is 5 to some power up here, right? Well, when you multiply like bases, you're supposed to add these exponents. So what we're really going to do is 1/2 times 3/8. Like I said, you're really going to want to either be able to do this manually or use your TI calculator. To add fractions, you have to have a common denominator. So I'm going to show you this one with a common denominator. 1/2 and 1/8, they have an eighth in common. So I'm really going to change this to something over 8 plus 3/8. And this would be a 4/8, right? 1/2 is the same as multiply the top and the bottom by 4/8. And that means that this would then be 7/8. That's how you would add the fractions. Now, if you wanted to live with the TI calculator, you would hit you would hit alpha y equals, enter on the fraction. you would do 1 over 2, arrow over out, and we're going to add alpha y equals fraction, number 1, 3 over 8, enter, and it's going to tell you, it's going to spit it out 7/8. So that's for the kid that doesn't want to work on common denominators or just wants to work on efficiency. I like you to know why the fraction comes out like that. That's because you add or subtract, you got to have a common denominator. But in this world, if it takes you too long to do it, I don't want that to be the problem. I don't want that to, slow you down. So use your TI. All right. For this next one, we have a power of a power rule. So we're going to multiply fractions. So when I multiply fractions, I do the numerator times the numerator and the denominator times the denominator. So that's 10. That's 3 to the 10 over 12. Okay? And that reduces to, 2 goes into both of those, 5, 6. You can type those in as well. You can literally type in 2/3 with the alpha y equals times 5/4 with the alpha y equals, and it won't spit out 10 over 12. It'll spit out the reduced version, 5 over 6. Okay? So then number 3, I'm going out of order. I'm going in order, but they're switched. I should have moved them. Anyway, we're going to subtract here. So this would be 9 to the 3/4 minus 1/3. We're going to subtract because that's the rule for division. When you divide like bases, you subtract the exponents. One thing is for sure, the 9 is the base. It's going to stay the same here in this question. We need a common denominator. So if you're a TI person, then you grab your calculator and you bang it in. If you are a manual person, you're going to switch these into 20s. So I'd multiply the top by 5, which would make it 15 over 20. 15 over 20 minus, and this is just me scratching it out, like thinking about it. And this would be times 4, so that'd be 4 over 5. So this would be 15 minus 4 is 11 over, whoops, that was 20. 11 over 20. All right. So I'm fairly certain you can probably then figure out what to do with number 4. Think to yourself, should I add, subtract, or multiply those? Add, that's right. So I would change these both into 15ths. That would be 5 15ths. That would be 6 15ths. 5 plus 6 is 11 15ths. And I'm going quick because you can do it in the calculator. If you knew that you were supposed to add these right here, you could do it. Number 5, this is really 2 over 1. So now I know what my numerator and my denominator is. I can multiply because we're doing the power of a power rule. That would be y to the 4/5. Okay. Last one here, we're going to use the power of a quotient, which we have to multiply all these exponents again, right? We got to multiply. Just so we know that's 6 over 1 in the denominator. This will be x to the 2/6. 2/6 is 1/3 over, this would be 12/3 if I multiply the numerator times the numerator and the denominator. 12/3 is 4. Okay? So we're just using the application of the rules you should already know to simplify expressions with exponents instead of fractions. All right. Now for the meat. Now for the real problems. Here we got 3 of them. If you need to pause them and pause this and copy them down, I'm going to go over them all, and then I'm going to give you a chance to try, okay? They just look a little bit more complicated, but trust me, I don't think it's going to be too much of a stretch if you understood those first 6. So first problem here, we have a product of like bases. So the question is, what do I do with the coefficients? You do what's between them. Coefficients, get the normal, whatever's between them, treatment. 4 times 1/2 is 2. Then you'll add these exponents. We'll add those together. And for those, I'm going to probably turn them up to 6s, powers of, or something over 6. So that would mean that this would really be 9 over 6 plus something over 6 for this would be 2 over 6, which means I have 11 over 6. So this would be 2x to the 11 over 6. Okay? This next one, I'm going to rewrite it slightly different just because you may see it different. You got to remember, what's the 1/2 power? Ooh, I need to go back. I need to go back. We need to type some more. Things to not remember. Or things to not forget. All right, maybe I'm going to type. Oh, I really want this huge. The 1/2 power is the blank root. The need to know the answers to both of those questions right there. The 1/2 power is the something root, and the 1/2 power, or the 1/3 power, is another kind of root. And it just escalates from there. They just keep going up. The 1/4 power is the 4th root, and so on and so forth. So you need to know that's the square root. So when we go back to that problem we were looking at, whoops, just gave you my angry face. We got the square root of all of this. So I'm going to rewrite it then. It really means the square root of 4x to the 3/2. Oh, that's terrible. 3. Y to the 1/3. Okay. Now that helps me because really not so much about this right here, because these I'm just going to multiply the exponents like it looks like it should. The 4 to the 1/2 is something we should understand though, numerically speaking. That means the square root of 4. So I know that this part right here actually helps me do the number to get it to the square root of 4. The rest of it, I'm going to kind of give it this sort of exponential rule treatment. I'm going to multiply it out. X to the 3/4, multiply across, y to the 1/6. That be it. Okay? So not too bad. Really the only reason I switched up the way that it was written was for the 4, the coefficient in the front. I wanted to make sure we could get on that kind of like our cheat sheet level, you know, where we have to use that to figure out the answer. You shouldn't have to use the cheat sheet for 4. Last one. I got -3/9. I'm going to give them the division treatment. That's what's between them. So -1/3. I'm going to subtract the exponents. Now, if you would so choose, you could actually move this to the denominator first, and then it would live downstairs with the 1/3, and you could actually add it to it. So maybe that's something I'm going to consider. You don't have to move it first. You definitely don't. So here's the way it's going to look like if you were to write it out. At -1/3, you have x to the 4/7 minus 1/5, and y to the -1/2 minus 1/3. Okay? And we're going to get common denominators, and we're going to do our subtraction. And we got -1/3. If I get a common denominator here, it would be 35. So I'd multiply that by 5. It would be 20/35. So I'm kind of writing this down. 20/35 on the side of my paper minus 7/35. So 20 minus 7 is 13/35. Okay. And then this one, the 1/2 and the -1/3. So that would be -3/6. And I'm just scratching this out. -2/6, and that would be -5/6 for the y's. I think the hardest part about this question is how are you going to write your final answer? Okay, because we do have this negative exponent thing with the y's. So I'm going to write this. I'm going to make a big bar. Actually, let's go this way because I got a lot of room. I'm going to go this way with it. I got a big bar. I got my negative sign in front. I got my 1/3. Anything with a positive exponent is going to live in the numerator. Anything with a negative exponent is going to live in the denominator, and it becomes a positive. So x to the 13/35 goes up top. Y to the 5/6 goes downstairs. Okay, there it is. That's your final answer. All right, so Don't forget, you can utilize your TI-84 if you want to do this math quicker without having to get a common denominator. This, for the video purpose, I think it's just valuable to see it all the way worked out. Your turn. Your turn. Pause it. Pause it. You ready? Here it comes. Ooh. There's your answers. The hardest one being number 3 again. Okay. Take a look at the work if you have to. Pause it here. All right, so number 3, just some talking points in number 3. Hopefully you don't hear the noise upstairs. They're putting on a board or something in the other room. This became a negative exponent when I got -1, so I moved it to the denominator. This became a -9, so I moved it to the denominator with the 3, okay? And I hope that's about all that it would need to be to help you understand exponent rules, especially with fractions. Use your calculator if you're struggling with your properties of how to add or subtract fractions or multiply fractions. All right, let me know if you need any help later.